Hi everyone, this is going to be our experiment 4. You need Erlenmeyer flask, 10 milliliter graduated cylinder, your unknown carbonate, weighing boards, spatula, and 6 molar hydrochloric acid, a timer, and a balance. So in this lab, we're going to find out an unknown carbonate. What's going to be the carbonate? An unknown metal carbonate using the law of mass conservation. So first thing, you're going to get the clean Erlenmeyer flask, 125 milliliters, and you're going to get the mass of the dry and clean Erlenmeyer flask. And record the mass in your paper. And then you're going to measure your unknown metal carbonate. And how many grams are you going to take? You need to take about 2 grams. First, you put your weigh board on the balance and zero the weigh board. And then you add approximately about 2 grams of your unknown sample into the weigh board. Measure about 2 grams. And you do not need to record this mass yet. What you're gonna do here is you take approximately 2 grams onto the weigh board, and you're gonna transfer that into your Erlenmeyer flask. And also make sure to record which unknown sample that you are using. It could be 1, 2, 3 or ABC. Record the unknown number. And then after you transfer your 2 grams to the Erlenmeyer flask, you take that flask, put on the balance, and you get the mass of the flask and your unknown. So this way we know exactly how many grams of unknown went inside the flask. And then the next thing would be we're going to be adding 6 molar hydrochloric acid. You take your 10 milliliter graduated cylinder. You don't have to get the mass of the graduated cylinder yet. So you're going to put 10 milliliters of 6 molar hydrochloric acid. It's going to be very concentrated. Make sure to have your goggles and gloves on throughout the experiment. Carefully transfer 10 milliliters of hydrochloric acid into the graduated cylinder. And then once you have your 10 milliliters in the graduated cylinder, you're going to get the mass of the graduated cylinder with the acid. Make sure to zero the balance before you get that, and you record the mass. And then you're going to pour that 10 milliliters into your 2 grams of your sample. At this point, you will see a vigorous reaction. You will see some gas evolution. And what is going to be that gas? What is it? What did you say? Carbon dioxide. Yes, because we have a carbonate. You add your hydrochloric acid, you are going to create metal carbonate, metal chloride, and carbon dioxide and water. So you will see that evolution of carbon dioxide. So after you pour your hydrochloric acid from the graduated cylinder, you have to get the mass of the empty graduated cylinder. Okay. So this way again we know how many milliliters of hydrochloric acid exactly went inside the flask. And you wait for 15 minutes, 10 to 15 minutes after you pour your hydrochloric acid. And while you are waiting for that time, you have to take the flask and swirl it time to time, so to make sure that all the carbon dioxide escape from our reaction mixture. After 15 minutes done, you're going to take it to the balance and get the mass of the reaction mixture. Make sure to zero the balance. Excuse me. So our law of mass conservation is mass of the reactants are equal to the mass of the products, right? So on the product side, now we do not have carbon dioxide there, right? And then the last step is neutralizing the acidic solution that we have or that we created. So you're going to pour your hydrochloric acid mixture into the waste beaker. Also rinse the flask with a few milliliters of deionized water bottle, deionized water, and same thing with the graduated cylinder that you had acid in it. You rinse that also with deionized water. And then we're going to check the pH of our solution. It's pretty red, meaning it's very, very acidic. Now we need to neutralize this. We use sodium hydrogen carbonate to neutralize this solution. When it is completely neutralized, you will see that the color of the pH paper will become yellow color. So after you add your sodium hydrogen carbonate, you can mix the waste beaker, and again here you will again see a vigorous reaction. That's going to be carbon dioxide devolution again, and then you can check the pH to see if it had come to the desired pH that we can dispose it without any trouble. Excuse me. So that was yellow in color. So you open the tap, and with plenty of water you're gonna pour that into the sink and let it drain. So that's the end of the experiment.